That should be the slides. Amazing. Okay, hi everyone. Again, my name is Márton Braun. I'm an Android developer advocate at Stream, and today I want to talk about the complexities of Android development. So whenever we're creating Android apps these days, we have a lot of choices to make, a lot of things to take care of in an application, and it got very, very complex at some point. And so this talk just started out as a bit of a rant about all of this, but then I figured that I want to sell this better whenever I'm trying to give this talk at conferences. So I found two angles for this. My pitch here is that you can use these things that I'm gonna enumerate here, both to improve existing products if you're working in more of a product company, or if you're starting new projects, for example, just on the side, or maybe you're an agency and you start projects from scratch for new clients often, then you can use these points that I'm gonna show here to better plan out and estimate your next project, because there's nothing worse than having to abandon some of the aspects of the project because you don't have enough time or money along the way. So it's better to have an idea upfront of what you want to accomplish and what you want to ignore. I've grouped these things very loosely into categories, and we're going to start with the UX related things. I'm not going to go into much detail in any of these things. I really just want to list all of the complex things on Android that you're supposed to be taking care of if you're a good developer, at least in theory. So under UX, there is accessibility for a start. There's no doubt that you've already met accessibility features on Android. If you've ever created an image view, you have seen this kind of warning that's prompting you to add a content description so that screen readers can tell your users what that image contains, even if they can't see the actual pixel contents of the image. One of my favorite things in accessibility requirements is tab targets. It's very important to get tab targets right in an Android application. Even if your designers are designing very minimal, tiny icons, you can add padding to that to comply to the material guidelines, which say that you should have 48 dp by 48 dp icons whenever possible, at least as far as the tab target goes. This is a minimum recommendation so that users have a good chance of successfully hitting buttons. I've had problems with this myself in applications that had very, very tiny, like overflow menus and icons like that. And you have to remember that supporting accessibility nicely is not just to support people who have some kind of specific permanent disability, but also for just enhancing the experience for users in general. Even if someone has fine motor control, for example, and usually uses their phone with two hands, there are going to be cases when they're using it in one hand because they have stuff in the other, and maybe they're in a moving vehicle at the same time. And at those times, whatever improvements you make to accessibility will make your apps better for other users as well. Speaking of making your app available to more users, there's the practice of internationalization, which is a huge topic, but I really just want to mention some quick aspects of it here. At the very base level, you can support translations by using string resources in your application and not hard-coding strings. Then you should also think about date formats, which are different region by region. Again, this is something that if you want to make the application feel native in a given language, then you should be using the local versions of it. Very similarly, the week starts on different days in different regions, so you should think about that, and for example, not design UIs which rely on each week starting on a Monday or on a Sunday. And of course, there are some places where text flows from right to left, and the expectation is that all of your UI will flip around as well. So it's also a good idea to occasionally test what your app looks like in right to left orientations or right to left configurations, just in case someone is using it like that. Again, just one small thing to highlight in this topic is that whenever you're using resource strings for translating your applications, you can use a special kind of resource called plurals, which let you specify different strings based on the amounts that you're passing into it. So for example, you can display different strings according to the grammatical rules of English. For example, if there's one song found or multiple songs were found, and put that on the UI. All of this is done by specifying which string is to be used for what quantities. And these can have a lot of different values because there are a lot of languages that have different concepts of how to use words around quantities. So there are languages that have concepts of few and many, and those amounts would have to be put into a sentence in a different way. Just something to pay attention to if you're translating your apps. Then let's talk a bit about dark themes. Dark themes are something that users are expecting today from Android applications. We have had system level support for dark themes for a while now, so you should really support it in your own apps as well. And Google also recommends that in a lot of cases, you also add a manual toggle within the app if it makes sense for you, so that users can choose to follow the system level setting or force a light or dark theme just for the individual application. You can also do things like follow the battery status, so that if the user has low battery and their device is in battery saver mode, then the application goes into dark mode, which conserves some more energy. Let's talk a bit about animations. Everyone loves animations on Android, and the reason we love it the most is that we have so many different APIs and frameworks to work with that we could use to animate things. And if you want to get started with an animation, you're going to go Googling and trying to figure out how to do this on Android. And you'll find articles like this, which promises to be an API cheat sheet for Android animations. And it's going to contain a flowchart like this, which will have all of the different cases and conditions in which you should use different frameworks for animating your stuff. I have some good news here, although the situation is quite complex. The good news is that there was a talk at Android Dev Summit a couple of years ago, which was a really great summary of how and when to use each animation API on Android, starting from the classic value animators all the way to things like motion layout. So this contains nearly all of the available animation APIs today, except perhaps for Compose, and tells you when and how you should be using them. Again, one tiny thing to highlight when it comes to animations is that some of your users are going to have devices where they have animations disabled. This can either be for accessibility reasons, because they don't like it when there's too much motion on their device, or it can be because they feel like their device is just faster if they don't have to wait for animations to complete. Either way, you should occasionally take a look at what your application looks like and behaves when animations are disabled on the device where it's running. For example, if you have something as trivial as this progress bar, this is a default Android progress bar that I have on the screen. If you have animations disabled on the device, you're going to see this static icon there instead. And you can spend quite a lot of time figuring out how that icon got into your application when you never edit something like this to your layouts. Also, if you're relying on animation timings for transitions between screens and such, that can also be a painful thing if animations are disabled and you're not doing things correctly. And the elephant in the room for UX choices and concerns is, of course, Jetpack Compose. So now we have two full UI toolkits that we can choose between when we are implementing our application. So this is yet another choice that you have to make, whether you want to do classic XML layouts or you want to build your UI in Jetpack Compose, which is the hot new thing. In the next category, I'm going to list some things that are very essential to the Android platform that we are very used to dealing with on Android. The first of these is going to be restoration, state restoration, because everyone learns whenever they start with Android development that if you rotate the screen, you're going to destroy your current activity instance, you're going to get another one, and whatever you've saved in the fields of that activity are going to be lost if you don't take care of it. So that's how we learn about configuration changes. We usually just call this orientation changes, so rotating the device. But the reality is that there are a lot more configuration changes that can happen. For example, the user can toggle dark mode or change the language or the font size. And all of these would also trigger the same behavior, and you would have to take care of your data and make sure that your state is preserved. This can mostly be solved by view models, but then there's also the question of process death, when your entire process goes out of memory and you have to recreate it from scratch and only saved instance state survives. So that's yet another thing that you have to take care of and remember when developing apps. Then, naturally, we have all sorts of different screens on Android. We have different resolutions, we have phones, we have tablets, all kinds of different screen sizes. We have screen classes between these that we have to worry about and have potentially different layouts in our applications. We also have different screen densities as a result. So we're used to shipping our assets, icons, images in different resolutions so that the correct one can be used on each API or each different density device. And since that was not enough complexity for us with all of the different kinds of and sizes of screens, we also have special screens now. So for a few years now, we've had these notches on Android devices, and we have APIs where you can query how many and what shape and where they are positioned. And you can use these APIs to make sure that you're not drawing under the notches in that invisible area of the screen. And because that wasn't enough either, we also have foldable phones now. And if you really want to perfect your application, you can query APIs that will tell you how the phone is being folded, and you can react to that dynamically and change your UI. Other than hardware settings, or hardware diversity, rather, and there's also software settings that you can change to make an app behave differently on Android. For example, you can change the font size, and for a couple Android versions now, the display size and the system level settings. Font size changes are fairly straightforward. I think everyone's familiar with this. Here's an example of a screen where the font size is changing. You can see that text is being broken up into multiple lines, and it's being reflown if it doesn't fit on the line. And you can support this essentially by just using SPs as your dimension resource whenever you're specifying font sizes. So this happens kind of automatically, but this is still something that you have to check on because some UI will be broken if you change font sizes unexpectedly. But we also have display size, which is essentially changing the density that the Android OS thinks the screen has. So this scales everything on the screen up or down, depending on which way you're changing it. In this example, you can see that the toolbar, the hero image, the buttons, and also the text, again, without changing font size, all are being enlarged or shrunk down based on the display size setting. So you should test for both of these kinds of settings in your applications and make sure that if someone sets these to the extremes, your application still looks somewhat correct. One of my favorite things on Android is app shortcuts. These are a not very popular feature as far as I see, but I really like apps that support it, so I want to highlight this briefly. You can add shortcuts to your application that can be accessed from the launcher by long tapping the icon. And you can put sort of static things here that are always an action that the user can take in your application. These are the easier kind. And you can also make these dynamic and personalized. For example, Spotify can provide you the albums that you've last listened to, and you can just have quick access to them through these shortcuts. This, again, is something that you should consider for your app, whether you have some actions and some user data that you can use to populate these shortcut slots and make your app easier to get into. Then let's talk a bit about notifications. Notifications are great because they get revamped on every major Android release. So whenever you have notifications, you have to test that they look correct on all of the different API versions that you support. You can have basic things in notifications. You can have text content, you can have some rich content like images, and you can put some actions in there that are going to call into your app whenever the user taps them. There are also custom notification styles if you're a special kind of application. For example, if you're a messaging app or if you're a media player, then you can have custom messaging styles or custom notification styles, like a messaging style that has replies inline inside the notification or suggested replies to the previous messages. And if you're a media app, you can have your playback controls, cover art, and all of that in a notification. If you're creating notifications on Android, for a couple of versions now, you had to create notification channels to send those notifications into. And there are some apps that are still really lazy about this. They have just a single channel called notifications and they send everything there. But it's a really good practice to have multiple distinct channels and categorize your notifications so that your user gets to turn them off or change how they are shown, perhaps whether they have a sound or not, for each individual channel. I didn't want to shame any apps here, so I just highlighted some of the better behaving apps which have a lot of different notification channels, as they should. Somewhat related to notifications is performing background work on Android. You might have seen that there are a lot of APIs for this that are integrated into the system now. We have at least 3 different kinds of managers that we have to work with. You can also run work in foreground services, and those are also tied into required notifications. And again, you can find a lot of lengthy flowcharts which will tell you what service or what manager to use at what point for background work. And this is just for long-term background work, so this doesn't even include things like all of the threading choices we have for short background things. Then, if you're developing for Android, you can consider going past phones, of course. For example, if you're a fitness app, it's a good idea to consider creating an app for Wear OS. And if you're a media app or you're a game, you can also consider supporting Android TV. In the second case, if you're a media app and you want to go to the TV, you actually don't have to implement a separate TV app. You can just implement casting support, and that gets you some basic integration, but there are also a lot of Android TV specific frameworks that you can build on for the full experience. And as you all know, hopefully, you can also take Android on the road. There are more and more vehicles with Android Auto support. So if you're something like a media player or a messaging application, you can consider supporting that platform as well. It's actually surprisingly easy to start supporting Android Auto in a media app, as long as you have integrated with the Android Media Session APIs correctly. Let's talk a bit about inputs, which is something that gets quite interesting on Android. So you know that most of the time when you're developing your application, you're testing it on a phone and using your touchscreen to manipulate the screen. But you are always going to have some users who have less expected input devices. For example, you're going to have users who have setups like this, because Android for a very, very long time now have supported external devices, for example, via USB. So if you're a productivity application, a text editor, or to-do app, it's a very good idea to check how your app works with mouse or how it handles keyboard inputs or keyboard shortcuts. That's something that you can polish for like your real power users. And if you're a game, it should come naturally that you should think about controller input. Android supports a lot of console controllers and also a bunch of third-party stuff. So that's also something that you can worry about if you're building apps. Okay, in the next category, I want to talk about QA, as in quality assurance. So things that you can do to make sure that your app is correct and polished. I'm going to start this off by talking about static analysis. For starters, you can just use lint inside Android Studio and all of the hints that it gives you about potential bugs and hopefully improvements that you can make to your application. But you can also take this to the next level with third-party tools. So you can integrate things like KT-lint or Detect, maybe run things like code analysis in Sonar and do it at a team level and so on. So this is a really deep topic. At the very least, you should be respecting things that Android Studio is trying to help you with. Then there's unit testing, which is the very basic kind of testing your application in an automated way. This already has a lot of complexity in it. You have to learn about how tests are set up, how JUnit 4 and 5 works. You have to choose between which one you want to use. There are a lot of helper libraries that you can use for your tests, whether you want to do mocking or whether you want to create fakes or generate test data. You want to parameterize your tests. You have to learn in the first place about mocking, spying, fakes, and so on. You probably have to learn about dependency injection at this point if you're creating unit tests. And at the end of the tests, you also have to choose your assertion library, which you also have a bunch of choices in. And then there are more complicated tests, like UI tests. So if you're running UI tests, in addition to everything that you are bringing over from unit tests, you now have to figure out where these are going to run. So you have to either have a physical device for this, or you have to have a virtual device in the cloud or on your own emulator or something like that. And you also have to learn about interacting with the view system from tests. So all of the curiosities of Espresso. Something you can do to make sure that your application behaves nicely is to do some performance profiling every once in a while. Again, Android Studio gives you the basic tools for this, where you can take a look at your CPU, memory, network, and energy usage. And this is a really good start because you can catch yourself if your app is spinning the CPU to 100% when you're not expecting it, or if it's making too many network calls that it shouldn't be making at that time. So this is a very good start using just the built-in profiler. But again, there are more advanced tools here so that you can dig down and optimize the performance of your app. Something very similar that you should do once in a while is looking at your APK size. We of course have app bundles now, which help a lot with this because they split all of the things that used to be in a single APK. For example, your resources for different screen densities or your native libraries for different architectures into different packages. But there are still a lot of things that you can bloat your APKs or app bundles with. So if you're including too many resources, too many native libraries, or things like that, you can still increase your app as you're building more and more features into it. So that's something you should keep in check because you're going to lose a lot of users at some point if your app is just increasing in size indefinitely. Okay, for the final category in this talk, I'm going to talk a bit about developer tooling. So first, let's talk about the choice of language, what you're going to code in. Of course, at this point, we have two primary languages on the platform. We have the classic way of coding in Java, and we also have the hot new thing, which is Kotlin. Okay, so this slide is really just a joke. We clearly know at this point where Android is going to go. So at least this one is something that we don't have to choose anymore. Something you do have to worry about is version control. Even if you're just developing alone, you should make sure that you're using some form of version control because it's a great way of keeping track of what changes you've made. And you can also separate features if you're developing things in parallel, for example. And then if you're working in a group, then version control is definitely a must because there's basically no other way of running a project smoothly. Once you have things in version control, though, a lot of things open up for you. For example, you can also add continuous integration on top of that, so that whenever you push stuff into your repository, it gets automatically built and tested, so that tests are executed even if you forget to run them locally. You can also publish from continuous integration, so you can move on to continuous delivery and ship either betas or the full final application straight to the store. Speaking of publishing to stores, the default for us is the Google Play Store, but there are also a bunch of alternative stores at this point. For example, Amazon, Samsung, and Huawei all have their own app stores where you can ship Android applications. The most interesting part here, at least as far as I'm concerned, is that some of these stores are going to support devices that don't have Google Play services on them. This means, for example, that if you want to support Huawei devices through their own store, which don't have Play services, then you're going to have to somehow isolate or remove things like push notifications with Google Play services or Google Maps or Google location providers from your application. And these are also quite a bit of work. So this is again something you should consider for your project, whether it's worth shipping to alternative stores or if you're just fine with the Google Play Store. Once you have your application published and you have users, you should have some idea of what's happening to your application. The most critical part is crash reporting, so that you know if your application is just failing completely out there in the hands of users. You get some basic crash reporting in Google Play, if that's the store you're using. but it might be a good idea to integrate some third-party tool. So something like Crashlytics, for example, where you get more detailed and more accurate stats of what's crashing so that you can fix your bugs. The happier part of tracking your application in production is analytics. So you want to know what your users are doing in your app, not just when it's crashing, but also when they're actually using it correctly. Or, well, when they're using parts of it where you didn't put bugs that are going to crash it. So you can add analytics to monitor when certain events happen in your app. This way you can see which features are being used, where users are getting stuck. If you have long flows in your application and you see that they're not completing them, you can figure out why that might be happening. You can see which features are not getting adapted and perhaps figure out what to do about that, and so on. Okay, so to bring this rant around, I pitched this as two things. Either ideas for improving your existing product, or ideas for your next project, so you can have a checklist and you can better plan out and estimate what you're going to work on within an app. But what I really want to bring this back to after all of these things, and I didn't cover half of these things that you should really take care of in Android development. What I really want to bring it back to is that you really don't have to know everything. It doesn't make sense to learn all of the APIs, all of the libraries, all of the frameworks, all of the practices and architectures that you could possibly ever use on Android, because that's not going to be useful for you at the end of the day. And it will make you worry a lot about whether you're up to date on everything. What's a good idea, however, is having a basic idea of what's available. And whenever you have to make a choice, whenever you have to start unit testing, or whenever you have to implement background services in an application, then take your time, research what tool you're going to use, pick one, and learn how to use that one specifically. That brings us to the end of the talk. If you want to grab these slides or check out all of my other talks, you can do that on my website on the link that you see on the slide. And if you want to follow me and listen to me tweet about Kotlin and Android and other stuff, you can find me on Twitter. That's the best place to do that. So that's Android complexity. Thanks for listening. And let's see if we have any questions in the Q&A section.
Yeah, let's check the Q&A section. Well, I think we have 2 questions yet. So you can go ahead and answer them.
Okay, so the first question is, do foldables actually require 2 separate windows for the 2 separate screens? Well, I'm going to admit that I have no idea. A perfect example of things I never had to work with specifically, so I never learned it.
That's a good thing that the other question is also about foldables.
Yes, we're very focused on foldables. I wonder how many people have these devices or want them. But for testing foldables, I'm actually fairly sure that there is an emulator that is going to help you do that.
Yeah, I think Samsung actually has their own emulator for the fold devices. If you want to try it out, so I think it's not built in to the Android Studio, but you can find it. I think maybe I will try and find the link if I can. Also, if anyone has any more question, feel free to write. In the while, I actually thought of something, Márton. I think what is very important in Android, and I think it's not an easy decision to make, is when to start testing and what test do you want, or what test you want to do first. So, for example, do you want just pure unit testing, or do you want to test with Android dependencies as well, or some higher level testing? So what's your thoughts about this?
Okay, great question. In general, I would, since UI testing involves everything from unit testing and also a bunch of other things that are really hard to get right and can go really wrong in unexpected ways, you should definitely not start with that. So whenever you're starting out with tests, unit tests first, certainly. Whether you need unit tests or not, and when you want to decide to get started with them, I think you I mean, you almost always need unit tests. You just might not see the value in them. It's really just a matter of realizing that there are bugs that you could have prevented with unit tests. And well, at some point you realize when you're writing really complex logic that that's something that you don't trust yourself to write correctly. Like maybe you have like a weird state machine and a lot of inputs and a lot of cases, and you've like kind of tried everything. Maybe you have date handling and you've tried selecting some interesting dates on your UI, and it seemed to work fine. But those are the hard parts of the code where you realize that you just can't trust yourself to test everything manually. I think that's where you get started. And then you
don't forget refactoring. Sorry to interrupt that. I think that's a very good place to when you have a big advantage if you have unit tests to cover that covers the existing logic.
Yeah, that makes complete sense. Yeah, if you want to touch existing logic and you are afraid of breaking it, then covering it with unit tests first to figure out how it works in the first place, and then to make sure that you didn't change anything accidentally. That's a must.
What do you think about UI testing? I think that's an interesting topic as well. It's not always the good choice in my personal opinion, but I'm interested in yours.
I think UI testing is great, especially for like smoke testing basic things, so that like your application doesn't crash on launch, or the main features can be entered and navigated through. I don't like to do a lot of unit tests because they take a lot of time both to...
You meant UI tests, right?
Oh, sorry, yes. So they take a lot of time to both create and then to execute whenever you have to run them, especially since you have to spin up like emulators for it or have real devices. And the complexity of setting up Android unit tests is something that I hate dealing with. Whenever I need to touch something in instrumented tests, it always ends up just hours wasted. And I don't know how no one can get Android UI tests to be easier.
Yeah. In the meantime, we received another question.
Yeah, the question is about manufacturers customizing the OS and breaking it and making system APIs behave differently. Yeah, that should definitely be on the list. I mean, it's not something that you can decide whether you want to deal with it, because at some point you're just gonna have to. It's just a matter of how long you can have your app in production without fixing that one bug that only comes up on Samsung devices.
Do you remember the time when one of the manufacturers, I'm not sure which one, maybe Huawei, decided to override the transparent resource?
Oh yes, I fight very hard to not have anyone on my team using built-in Android colors, because...
Yeah, I can very much relate. Yeah, that was my conclusion as well. That you should even create your own resources for things like transparent and white and black.
Yeah, we definitely have all of those.
Yeah. I think that's a good tip. Yeah.
Yeah. So that's. I mean, I guess you can decide whether you want to support all of these manufacturers that are breaking system APIs, but at some point you're going to have enough devices where you have to support it, because it's going to be a significant amount of users.
Yeah, and remember that issue as well. I think it's still a standing issue, but it's more or less mitigated for the background running applications. You know, there's a site, don'tkillmyapp.com. I think that details it very much. I think that's another point where manufacturers are pretty much customizing the OS up to the point that it's really a pain for almost everyone, users and developers alike. Wow, yeah, questions are coming up, so I think we can mark this one, answer the manufacturers breaking. Yep.
Yeah, we have a question about how complex Android is compared to other platforms like iOS. I have no real iOS experience, so I'm going to skip this. Do you have any thoughts on this?
Yeah, well, if you don't mind, I can shed some light into it, because I actually develop for iOS as well. Although I have to say that in the recent months and almost a year, I had not too much time to spend on iOS. But anyway, so I think both of them have their own own quirks and everything. You know, Well, I think the biggest difference. So I don't want to go into too much details, but the biggest difference I think is the abstract stuff. So on Android, I think that the feeling that you get when developing is that you can customize and tweak everything up to the smallest level, and that has the biggest complexity as well. On the other hand, on iOS, I think you are pretty much restricted in a bunch of ways. So it can seem easier to start and easier to get some stuff. Although on the other hand, if you run into a wall, it's really a brick wall, and it's sometimes it's very hard to do the thing that you wanted to do. So it depends how you look at it. I think both of them have complexities. I think starting iOS development is a little bit easier, especially now with the Swift language. I think back in the days when Objective-C was the only language on iOS, it was very different because the language itself was a big barrier for entry. But in Swift, it's very similar to Kotlin as well. I think it's a good convergence as well, that you do things very similar. And also now Jetpack Compose UI, it's also very similar to Swift UI. I think it's a good thing that they converge a little bit. So yeah, that's the high level stuff. Again, I don't think time to go into details, but I hope this somewhat answers the question.
Yeah, I think it does. If I have one opinion about it, I really like Swift as a language. It's still not Kotlin, but it's a really great language, and it's great how similar they are.
Yeah, I agree. Go ahead. So next question.
Yeah. So how can we test apps on multiple manufacturer-specific custom ROMs? Do we need to buy those, or do we have emulators? Well, that's a tough question. I think at the end of the day, you use real devices if you want to get rid of all the bugs and reproduce all of them. Because even if you're trying to emulate specific ROMs, you're going to have trouble with it at some point, which means that there are just going to be some bugs that you'll never reproduce in your own device, unfortunately, because you can't have in stock.
Yeah, I think a good tip to add here is this sponsor of us, but for example, Bitrise has tools to test on real devices, but there are also other tools as well. From my head, I can't remember anything else, but there are definitely different where you can run your code on real devices that are somewhere in the world.
Yeah, and if you have tests, for example, you can use Firebase Test Lab to run it on real physical devices.
Yeah, good. That's good.
Also, if you need to support things like Huawei's like own SDKs, which I've mentioned earlier, when you don't have Play services, they also provide kind of emulated or perhaps real devices that you can remote into. Samsung, I think, has something similar. So yeah, you can try getting to some point with these, but eventually you're going to have to use real devices, which is a real shame.
Yeah, I think it very much depends on the company size as well, what you can afford to have. I think it's reasonable to check what's the most popular devices, and also maybe the ones that are the most problematic, and maybe get a bunch of those. I would like to add a personal experience to this, which is I think funny, is that even for one single this type, there are many different variants. And in my current company, I have to deal with very low-level USB connections. And you cannot imagine how many differences can be between just country variants, same device. For example, the Samsung J3. I think there is around 60 variants for that device. That one single device. If you want to see on the internet, it's the Samsung J3, and there's a year attached to it as well. So there's a J3 2018, 2017. Even one of them, for example, J3 2018, has 60 different country variants. And the USB stack, the lower USB stack, is different. Not all of them, but some of them. So that's something to try to debug.
I feel like using USB stuff at that low of a level must be very similar to using Bluetooth on Android.
Yes. It is. I did it as well, and yeah, it is similar.
Okay, there's a note in the questions about just supporting 10 previous OS versions. Yeah, I guess I didn't mention that either. Another good point. Yeah, just having to branch your code based on API versions. Although I feel like in a couple of years now, I had to write very little code that depends on that. I guess I'm just lucky that I'm developing apps and features that are covered by Android X stuff.
Yes, yeah, that helps a lot. And also, going back to the previous question, talking about different kind of devices and device variants. If you multiply that or try to also test with the different versions of Android that they support, that's exponential growth in complexity. But in most cases, most applications, you don't need to deal with that. I think usually, but yeah, if you do some lower stuff, especially, then it can be very very complex very fast.
Oh yeah. So you should have like each specific Samsung device, and you should have 3 of them for Android 7, 8, 9.
Of course, that's not feasible, but yeah. Not even for a big company, I have to say, but yeah, I need to get to a point. Yeah, I think there's one last question. I think there's time for one question, so that's good.
Yeah, let's do one last question, and then we can have a small break before the next talk. So the last question is that Compose is now here, and people are already calling XML layouts a legacy. Should we still stick to it or move to Compose? Do you have any opinions on Compose?
Yeah. I actually did the Android Dev Challenge recently. Interesting. I won't say that you should call the XML layout system legacy yet. I do think that it will be future focus very much for Google, and I think it's a good idea if you can to at least try to learn it. And also, I think I read a recent tweet which was very interesting, is that it urged people working in smaller companies to jump on Compose, because in a small company you have an advantage of moving fast, and it's not a big problem if you break something, and big companies can be slow to adapt, and I can very much say that it's true. So that can be a decision point, but I don't think so that it's we are at the point that it's a legacy to write XML layouts. What's your opinion about it? I guess you have also a bunch of experience with Compose, I've seen.
Yeah, I've been playing with Compose and I really like it. I would be happy if all we had is Compose now, but I feel like it's gonna take a lot of time for us to migrate. It will be somewhat similar to the Java to Kotlin migration. So new things are probably gonna be more and more in Compose as more companies adapt it, but like we're always gonna be touching XML based layout stuff for like, I don't know, like 5 years or something, if Android still exists. So it's probably going to be long years while we still have some amount of XML to deal with. Old projects, old features. We're not going to rewrite everything, so we're going to have to deal with being in transition. But I'm really happy if we're seeing more and more Compose.
Yeah, and I think it's going back and again for a previous question. I think it's very interesting that both iOS and Android moves in that direction, because Swift UI on iOS is a very very similar concept. It's also only available for Swift, and it's a very similar concept. Okay, yeah, I think that was the last question.
Arguably both are just copying Flutter at the end. So
yeah, I mean, Android literally copies Flutter. I don't know if you remember. I think we were in the same conference, and they in some presentation they found out a comment from the Jetpack Compose code that mentioned Flutter. So they just copy pasted it.
Yeah, you're great people cycle ideas or something. There's a quote about this.
Yeah, even Google does this sometimes. Okay, yeah, thank you very much for your talk.